we're still perfectly in time, and we will now go on with our speaker, Mirko Benz, from the well-known company BAUMER. And Mr. Benz will give us an overview about latest camera technologies, which will address challenging applications. So, Mr. Benz, the stage is yours, and we are looking forward to your presentation.
Thank you very much. I hope you can all hear me. Yes, as said, starting a new session for camera technology. I'm working as a product manager for BAUMER for high-end applications. So this talk is more about specific requirements that we see, as the title shows here, for challenging applications. How can I go to the next one? This one. Okay. Thank you.
Due to the current COVID-19 situation, please note the general hygiene rules.
I do.
A minimum distance of 1.5
Wir haben Zeit.
must be observed. You are required to wear medical mouth and nose cover. Follow the requirements of the currently valid corona guidance.
Okay, so that was also important. I would like to start my presentation with a little overview of our company, BAUMER. BAUMER is an international family-owned business. We have headquarters in Switzerland. We have a very broad portfolio of industrial sensors for position detection, for example, for distance measuring, but also a broad portfolio of encoders. I'm from the business unit Vision Technology, where we produce also a broad portfolio of industrial cameras, mainly for factory automation, as you can see here on this right side. We produce cameras for already more than 20 years, so we have very broad experience also with very diverse applications. Of course, as I'm more responsible for high-end applications, we also see more demanding requests here. Some of the applications that our customers solve by using our cameras are shown here. Of course, typical factory automation applications like printed circuit board inspection, but also for paper production are used with our cameras. But as the introduction in the morning told you, non-industrial applications are also getting more and more popular, and we see this also for our cameras, as you can see here on the right side, for example, with pantograph monitoring or medical equipment, but also for sports applications. So we basically cover already a very broad range of applications beyond factory automation. Of course, we see a multitude of challenges from these applications, and I can tell you every application is different, so it all has its specific needs and requirements. But basically, what we see from a lot of applications is that there are three common requirements, like the individualization of the production, the overall equipment effectiveness is very important, but also the total cost of ownership. When you do inspection and automation, then of course all three aspects are very important. From our perspective, we put the customer into the center of our product development and on all the aspects that drive our business. And I want to show you some of the aspects that we developed over the last 2-3 years since the last Vision Show in 2018, starting with reliable imaging, image analysis, up to one-stop shopping, so broad also different aspects of what our customers request from us to better solve their application. I would like to start with reliable image analysis. Of course, this is a very basic requirement. If you can't see the properties that you want to inspect, then it will be very difficult to solve your application. We provide better image quality with the latest cameras that we have. We do this, for example, by integrating the latest sensors. For example, the fourth generation of Sony with backside illumination. This clearly brings a much better image quality when we compare this especially to older CCDs or older CMOS sensors. So the images are really drastically better in terms of noise performance, for example, homogeneity and dynamic range. For some applications, it might be very important to have a very high signal-to-noise ratio. For example, for metrology, there it's very important. We support this by also integrating more specialized sensors, for example, the third generation from Sony, which provides a dramatic improvements for signal-to-noise ratio, almost 50 dB, which is very high when we compare this to older sensors. Of course, it's also important to have very homogeneous images without artifacts, and this is really greatly improved with the latest sensors. For example, we integrated the G-Pixel 65 megapixel, and when we compare this to older CCD sensors or older CMOS sensors, then you won't see any stitch offset, for example, and you don't have to work around such sensor effects, which greatly simplifies your job when you do image analysis. Of course, higher resolution is also very important. We get this request all the time. For example, code sizes are getting smaller, and when we made this presentation, we were just comparing what we had at 2010. Then a 5 megapixel CCD was very popular at that time. As you can see, we increased the resolution now up to 65 megapixels, so a factor of 13 over this decade. Clearly, this provides you to see more details of the images that you acquire with our cameras. Another advantage here is that you can use a larger field of view. So for example, for inspecting very big objects, or you can even replace multiple older, smaller resolution cameras by a single, very high resolution cameras, which simplifies also your setup and makes overall the image analysis easier. And one third aspect here is we integrate here global shutter sensors. So there are no motion artifacts as you would encounter, for example, with rolling shutter sensors. We also bring down the minimum, the short exposure time, to 1 microsecond. This is important for very fast moving objects where you still want to see no motion artifacts. But of course, then you need a very powerful illumination, but also very good sensitivity from the sensors. We support this with very large pixels, up to 9 micrometers. So this is really important when you want to capture images at such short exposure times. All our cameras are based on FPGAs. For the high-end cameras, we use very powerful FPGAs, and this enables us to also add a lot of image processing functionality already within the camera. So not relying always on the PC, we do some of the processing already within the camera, and there are two main important aspects. One is the reduction of the CPU load. If the camera is already doing the work, then the PC does not have to do the work and is free for your application. And another big advantage here is reduction of the amount of data that needs to be transferred and handled by the PC. I've shown here 4 examples. Left top one is a shading correction. Left image original, right one is a processed image. Again, these are images already provided by the camera, so very easy to use with all the third-party software out there. And as you can see here, we can get rid of effects of lenses, for example, where you will see some shading effects in the corners, but also of inhomogeneous illumination. And clearly, this makes the image processing much easier. On the right side, top image, you see high dynamic range image. This is also a request we see quite often. There are applications that want to inspect with a single image very dark and bright areas in the same scene. And we do this by combining 2 images with a high gain and low gain for Sony sensors, or a single image with different exposure times based on lines for the G-Pixel CMOS sensors, for example. We compute then an HDR image that is directly transferred to the PC for further evaluation. We have very big customers in microscopy applications, for example, so already quite long experience with this specific applications. We are very happy to also now make this technology available with standard cameras. For example, we integrated a very high-end quality color processing based on a 5x5 environment, but also edge sharpening and noise reduction for such color images. You can see the difference left to right, standard color calculation and our improved color calculation, again, already integrated in the camera. On the right, you see an image compression. We integrated here JPEG compression. We can do this at full performance of the cameras. And here shouldn't see any difference from the left to right, but I can tell you the data reduction is about by a factor of 10. So really you can use an interface of 10 gig that would be otherwise needed, and now you can use just 1 gigabit Ethernet. So this greatly simplifies also the equipment and makes usage of switches, for example, easier, or mobile laptops, for example. Of course, resolution is one thing and image quality, but also customers want inline inspection. They do not want to do inspection just for every 10 part or 10th part. No, they want to do it nowadays for each part. And to make that happen, we need to improve also the speed of the inspection. We do this by integrating the latest CMOS sensors, as you can see here, second, third, fourth generation from Sony, now up to 24 megapixel is available, but also the latest high-resolution sensors from G-Pixel with 65 megapixel. As you can see on the left side, depending on the resolution, we can use more than 2,600 frames at quite small resolution, but still high frame rates, even at 8K high-resolution images. Furthermore, we have more sophisticated sensor readout, so not just the basic full image, but for some applications, 2x2 binning, for example, is really important to get higher sensitivity, but also by using the sensor feature, we can offer 3 times the frame rate. This is important for applications that want to have this very high frame rates. For other sensors, for example, the G-Pixel, we offer 2x2 subsampling, also to roughly double the frame rate for applications where this is needed. Data reduction is also supported here by multiple regions of interest. For applications that do not need the full image, we can just transfer areas, and then, of course, the amount of data is reduced. And on the right side, you can also see that we can program the camera by using the sequencer with certain features like exposure time or output to really have parameters per image. So this gives you a great deal of flexibility. What kinds of interface are we supporting? In general, GigE, USB, of course, for the mainstream applications. Here, for high-end applications, we have now 10 GigE, so 10 times the bandwidth, but with a standard GigE Vision technology. So really great performance and all the benefits that you know from GigE Vision, like very long cable lengths, especially with our fiber option. As you can see here, it's a network card, so you don't need a frame grabber. Very low-cost network cards in sort of 100 euro can be used, and 10 GigE is clearly the most cost-effective interface for such a performance class. Of course, there are also applications that need multiple cameras, higher scale of camera numbers. For these, we support specific network cards, now up to 100G, so 10 times the amount of data of our cameras, and also specific software to have a kernel bypass, which allows to have really zero CPU load for the DMA transfer. As you can see here, in the middle, we use switches, standard industrial switches, no components that are only developed for our relatively small industry. For example, with a number of 10 GigE ports, we can directly connect the cameras, and with some 100G uplink ports, we can go to the PC over various ports. The main advantages that we have here is that we can now use hundreds of gigabits from these cameras and use them with a single server class PC. So, and still, we have very low CPU load based on the advantage of DMA. And it works, of course, with Windows and Linux, and also with a GPU, because this is technology also developed by NVIDIA. And it's future-proof. The network cards that we use today have 2 ports of 100G, so 200G, already 4 times as much as the common core express technology, and this will go on and on for the next couple of years. Already 400G network cards are under development. We see this as a great alternative to other high-speed interfaces. Some aspects like this switching, supporting of hundreds of cameras is only supported by this technology. Of course, when you have the speed, when you have the resolution, and you decide at some point you want to integrate the camera, and here we also have put a lot of effort into simplifying your job as a system integrator. For example, we provide with our latest camera direct lens control, so you can fully automatically, electronically configure the aperture and also the focus of liquid lens, very fast moving objects, but also for Canon EF for higher resolution when speed is not that important. And in the middle you see that we have multiple inputs and outputs, so for more flexibility in your application, and we can also directly control other devices with a UART, for example, directly from our camera, which is quite handy, especially if you want to do this over a longer distance directly via the GigE connection. And on the right side, you can see we have directly integrated already within this camera a lighting controller supporting up to 120 watts. So this is quite a lot of power that is available to directly drive illumination without the need for external components. Some of our applications are also needed for harsh environments like outdoor, for example, or railway. Here we support specific connectors like M12, which are more robust compared to the standard RG45 connectors. We also test our cameras against railway standards to really make them work for a very long time. In the middle, you can see our patented tube system, which covers the lens so that it cannot be changed. And it also has the advantage of a higher protection class, up to IP67. So really dust and waterproof designs are made simpler without an external enclosure directly from the camera. And on the right side, especially for applications that need this -30 up to 65 degrees temperature range, we specifically selected the right components to make this happen. Of course, the camera is, yes, our center of focus, and the main development are put into this, but we understand that a camera is just one component and others are needed as well to make a solution, and therefore we qualify a lot of other components, as you can see here, from lenses up to cables and so on. And of course, we also make them available in our portfolio. If you start with 10 GigE, for example, use the starter kits that we have here, make use of pre-qualified components that are ready and known to work, and are also supported by us. And as you can see here, basic one-stop shopping for all the components that are shown here. And final slide from my side. What I wanted to show you here, yes, it has been 3 years since the last Vision show. We have been very busy, as you could see. We developed a lot of great technology, especially for the high-end cameras, higher resolution, higher speed, more functionality, and so on. But of course, there's a lot of more technology that you can discover at our booth, 8D40, just around there. And as you can see here, there are a lot of other innovations that we would like to show you and demonstrate you. Come to our booth and talk to us. Thank you very much.
Okay, ladies and gentlemen. There's room for one question. So the question is concerning the FPGA pre-processing on the camera.
Yes.
Is it possible that the user can adapt some of the functionalities and maybe, if the user thinks so, improve them?
We had some experience with user programmable FPGA cameras and can tell you that this is not an easy task to do. Therefore, we decide to do this ourselves based on the requests that we get from the market, what are typical needs that many applications have, and that's something we implement into our cameras. Of course, if you get back to us with a specific project, we're always open for discussions, but with this specific cameras, we do not offer user programmable applications. We do this with other cameras that we have, for example, with our AI-ready smart camera. And I would really recommend to try this out.
Okay, thank you very much. Again, thanks, Mr. Benz.
Yeah, thank you.
Danke.